Welcome to your online source for calculator tutorials. In this tutorial, we will use our calculators to perform a series of empirical trials involving the flipping of a fair coin 100 times. To accomplish this, we need to think outside the box a little. If we tag the event a head with 1 and the event a tail with 2, then all we need is a way for the calculator to randomly select either 1 or 2 100 times. And then we need some easy way to view the results. Turns out that we can do both fairly easily. The command we need is the random integer command located in the probability tab of the math menu. You may recall this tab from our results involving permutations and combinations from another tutorial. The random int command is located at number 5 in the menu, so go ahead and hit 5. This command has 3 arguments. The first 2 arguments give a range of numbers to choose from. We only want the calculator to pick either 1 or 2, so we should set those as our low and high values respectively. The third argument, you need commas between each argument. The third argument that we're going to enter is the number of times that the calculator should do this. For this particular example, we're looking at 100 trials. Go ahead and close up the parentheses. And so let me just make sure we understand what this command's going to do. It's going to pick a random integer, meaning a random whole number here. It could be negative numbers if we gave it that range, but a random integer between 1 and 2, including 1 and 2, so those are its only 2 options, 1 or 2, and it's going to do that 100 times. Go ahead and hit enter. What you'll see is a string of 2s and 1s. Now they're not in any particular order. This is supposed to be random, so this is just a string of 2s and 1s. What we would like to be able to do is put that string into our list, and we can do that easily by hitting the store button, followed by second 1 to bring up the L1 list variable. All of the list variables are the second function of the key variables or key numbers. So if you hit second 1, that's list 1, second 2 is list 2, and so on. So we're going to store this to L1. Go ahead and hit enter, and it'll just replay the string. But if you go into the stat menu here in the middle of the keypad and hit edit, the very first option you have, this will take you into the list environment, and it'll show you in our list 1 all these different values. Alright, so step 1 of the process is done. We've managed to store a list of trials where 2 represents a tails and 1 represents a head. We've done that 100 times. But we really want to be able to view our results, and we need to find a better way than just simply going down the list and counting what we got. Probably the best way to do this is to sort the information into a bar graph. To access a bar graph, simply hit second y equal. This will take you into the stat plot command or the stat plot menu. By default, all the plots are turned off. What you need to do is go ahead and hit enter when you've selected the first plot. And we want to change the plot to on, so go ahead and hit enter again. Move your arrow keys down, and you want to select the bar graph icon. Since we're going to be doing a bar graph, this will change your X list, meaning your data values are found in L1. That's true, so I don't need to change that. And the frequency of those data values is 1, meaning if a 1 appears in the list, it's only counting 1 time. Alright. After we're finished with that, we can go to our window because we're going to need to set it up to get a proper view. Our X values here are always going to be either 1 or 2, so we can make our X range from 0 to 3, and that should give us plenty of view of what's going on. The Y values are the number of times that a 1 or a 2 are flipped, so this could be anywhere from a 0 to 100, but it's very unlikely that, since this is random, any one value is going to be picked 100 times. That would have an astronomical probability, and I encourage you to try to calculate the probability of that happening. The Y max here, probably something like 75 would be plenty. And let's change our scale to 15. Alright, if you go into the graph and look at the graph, we have, looks like 2 identical bars, so it must have chosen 50 of each. If you hit the trace button, you can use your arrow keys to move back and forth to the different bars, and in fact you can see here that n is equal to 50. So we had 50 heads and 50 tails, so that's not always going to happen. That's what we would expect the theoretical probability to be, is 50 of each. So let's, just for the sake of getting some different data, let's go ahead and repeat this quickly and see if we can't come up with some different results. Go ahead and hit second mode to quit back to the home screen. And I want to hit the second enter button to recall my entries until I get back up to that random integer command we used earlier. So I'm going to hit enter again. It should produce a different list. You can see the values in the 2 lists are different now. And I want to store this new list back into that same L1 variable. So this will overwrite the list that we have in there currently. And if you go back into the graph now, what you should see are different bars because we performed a different set of 100 trials. Now this time we get some better results. This time we get some results that are a little more close to what we would expect. If you hit the trace button, you can go on to the first bar. The first bar is the 1 bar, so it's the number of heads. We recorded 59 heads and 41 tails in this trial. So those would be considered the empirical probabilities, but I think we know theoretically that they should be exactly how they were on the first trial, and that's a 50-50 split. Now remember, what happens is as you increase the number of trials, you get closer and closer to the theoretical probability. So if I was to increase this to say 1,000 trials, we would expect to be a little bit closer to a 50-50 ratio. If I was to increase it to 1,000,000, once again, we'd expect to be a little bit closer. Alright, this concludes the Performing Empirical Trials tutorial. Feel free to replay this tutorial or browse any of the other available topics on the course webpage.